Ever wondered what gives fruits like bananas and pineapples their delightful aromas? Today, we begin our journey into the captivating world of esters. These organic compounds are much more than just chemical curiosities. They are nature's own scent makers and versatile chemical intermediates that shape the flavors and fragrances we experience every day. In our exploration, we will break down their definition, formula, properties, examples, formation methods, uses, and reactions, all while connecting theory with practical reality. At its core, an ester is an organic compound characterized by the functional group Arfur-Or, where the R and R groups can be varied. This arrangement emerges when the hydroxyl hydrogen from a carboxylic acid is replaced by an alkoxy group derived from an alcohol. In simpler terms, an ester is what forms when a carboxylic acid meets an alcohol in a reaction that transforms both into something uniquely aromatic. This defining process not only alters the compound's structure but also its overall behavior in chemical reactions. Chemistry students, picture this. The general formula Arfur tells us that the molecule is a blend of two fundamental building blocks. The R segment originates from the acid, and the R segment comes from the alcohol. Such a visual can greatly aid in grasping how the molecular geometry influences its properties. The simplicity of this formula belies the profound complexity of the reactions and properties that esters exhibit. Even as we proceed step by step, the elegance of their structure remains clear and engaging. Esters boast distinct characteristics that make them stand out. Known for their pleasant, fruity aromas, they are responsible for the signature smells of many fruits and flowers. For example, isopentyl acetate is found in bananas, delivering that unmistakable banana-like fragrance, while ethyl butyrate is what gives pineapples their alluring scent. Consider that these aromatic properties not only contribute to our enjoyment of everyday experiences, but are also crucial in various commercial applications, from flavoring agents in the food industry to key ingredients in perfumes. Amazing, isn't it? The formation of esters, a process known as esterification, is both fascinating and instructive. This reaction typically involves mixing a carboxylic acid with an alcohol in the presence of an acid catalyst such as sulfuric acid. During this chemical dance, a molecule of water is expelled and a new ester is synthesized. Visual aids like reaction mechanisms and diagrammed steps help demystify this process. To the naked eye, it might appear as a simple exchange, but each step carries an intricate interplay of bonds forming and breaking under precise conditions. Our discussion would not be complete without acknowledging the myriad uses of esters. They play a pivotal role in industries that affect our daily lives. Solvents derived from esters are common in paints and varnishes, ensuring smooth applications and vibrant finishes. In the realm of flavoring and fragrance, esters are indispensable. Their bright aromatic presence enriches foods and perfumes, elevating simple ingredients into memorable experiences. Additionally, esters such as polyethylene terephthalate, or PET, form an essential part of modern plastics, contributing to the manufacture of robust fibers and containers. Impactful. Esters also engage in dynamic chemical reactions. Under the right conditions, they can undergo hydrolysis, breaking down into their original carboxylic acids and alcohols. This reaction is catalyzed by acids or bases. When bases drive the reaction, it is commonly known as saponification, a key process in soap making. Such chemical behavior underlines the importance of understanding reaction conditions and highlights the multifaceted nature of these compounds in both academic and practical contexts. Today's exploration has guided us through the nuances of ester chemistry, from basic definitions to intricate real-world applications. The clear connection between molecular structure and observable properties not only deepens our appreciation of chemistry, but also empowers us to think critically about everyday phenomena. As we conclude, remember that the study of esters is a gateway to unlocking the secrets behind the flavors and fragrances that color our world. Explore the fascinating world of esters and discover how these compounds influence flavors, fragrances, and even the materials we use daily.